Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Module 14, Transport Layer. We're going to be looking at the transportation of data. Basically, we're going to be looking at how the transport layer manages the transportation of data and how it works with end-to-end communication. We're going to be looking at the two main protocols that operate at this layer, TCP and UDP. We're going to be talking about port numbers, how they function, and their role in communication. We're going to look at the TCP session establishment process and termination process. Again, that's TCP and kind of how it functions. We're going to look at reliability and flow control, and we're going to end with UDP communication. So, jumping right in, transportation of data. The transport layer is responsible for the logical communication, the application functionality on one host and the destination host. The link between the application layer and the lower layers that are responsible for the overall network transmission. Again, transport is about being able to deal with the application on source and destination applications. The transport layer is responsible for tracking of individual conversations, segmenting and reassembling data, adding in the layer 4 header information, identify, separate, and manage multiple conversations, both creation and termination if necessary, and multiplexing of that conversation to kind of interleave on the same network. So we're going to be looking at the transport layer both locally and on a remote network. What we have to look at are the different protocols and how they operate. So at the transport layer, we have two main protocols, TCP and UDP, Transmission Control Protocol and User Datagram Protocol. Those are the two major protocols. How they operate are slightly different. TCP provides reliable and better flow control. Basic operations of TCP is essentially a number and tracking data segment that will be transmitted to specific hosts on specific applications. They will acknowledge the receipt of that data, and if they don't get an acknowledgement, they will retransmit data. They will also sequence the data so that if the data is received in the wrong order, the end device knows how to repackage the data so that the data it can be reconstructed. Sending data at an efficient rate that is acceptable by both the sender and receiver is part of this flow control. Basically, they have to agree on how much data can be sent and received at one time. In contrast, UDP provides basic functions for delivering datagrams between the appropriate applications with very little overhead. This is known as a connectionless protocol and is best effort. There is no acknowledgement, there is no guarantee, there is no retransmit. It will try to send data and you will either get it or you won't. And that is it. UDP is really good for things that require real-time traffic. The low overhead allows UDP to send data faster, even though it's not as reliable. If you need reliability, it's going to be TCP. TCP is reliable, it does retransmit data, it does acknowledge when it receives data. UDP does not. UDP also doesn't organize its data. It will send data, and however the receiver receives it, that's how it's put together. Where TCP will actually restructure the data based off of a sequence number. So let's go ahead and let's look at TCP more in depth. Again, TCP will establish a session. It's connection oriented, meaning it will negotiate and establish a permanent connection between the source and destination prior to sending any data. When it's done sending data, it will actually terminate this session. TCP will ensure reliable delivery of data. If it doesn't get delivered, it will retransmit. It also provides same order delivery. Essentially, the sequence numbers allow for the data to be reorganized by the receiver. It also supports flow control. Basically, if there is a congestion part of the network, we can actually implement flow controls to control how much data is going to be sent and at what speed. Basically, ensuring that we're not overtaxing a link. The TCP header will have a source and destination port number, a sequence number, an acknowledgement number, a window, checksum, and other control data. Source and destination are going to be the source and destination application ports. The sequence number is going to be a 32-bit data used for reassembly. An acknowledgement number is used to indicate the data has been received. Header length is the 4-bit field known as the data offset, and that will indicate the length of the overall TCP segment header. The reserve is a 6-bit field that is reserved for future use. The control bit is a 6-bit field used to include bit flags. Window size is a 16-bit field used to indicate the number of bytes that can be accepted at one time before an acknowledgement is sent. Checksum is a 16-bit checksum, and there is a urgent field that's also 16-bit, and it is used to indicate the data it contains is urgent or not. Again, TCP operates at layer 4. It will take an IP packet from layer 3, and it will then translate to higher application layers like HTTP or FTP or SSH. These are all things that use TCP for its main transportation protocol. Alright, so let's go and look at UDP. So UDP is reconstructed in the order that it's received. There are no resending of segments that are lost. There is no session establishment. There is no sending information about resource availability. It sends data and its best effort. That's it. You'll notice that the UDP header is way simpler. Source port, destination port, length, subnet, that's it. Everything else is done at the lower levels. The header, again, source destination ports, the length, and checksum. Checksum is just used for errors. This is a simplified header to ensure that data is transmitted as quickly as possible. This is going to be anything that allows for a real-time component. Video, voice, anything that doesn't need reliability. So things like TFTP or SNMP, DNS. These are all very simple protocols that basically are like a request and reply type application. There is no retransmit when we deal with UDP. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.